Well, welcome to another episode of the Grazing Sheep Podcast. I'm your host, Big Tom Perkins, along with Dr. Cameron Meyerly. And today we're joined by Dan Poole from North Carolina State University. Did I get this one right this time? Because
Yes,
when
You
sir.
I say the other one, I catch all kind of flack over that. So I don't want to screw this up too bad. But Dan, you are proficient in breathing. Is this correct?
That's correct. So I'm on the faculty here at NC State, and my job involves reproductive physiology. So basically, animal breeding and understanding how ruminants breed. So I do work in both cattle and sheep and goats, um, and so got my start actually in 4-H in Pennsylvania years ago. I was telling Big Tom earlier, I grew up about an hour south of him
Yep.
in Fayette County, and was very fortunate to be involved with 4-H and showed everything under the sun, except for sheep, surprisingly. And that was mainly because Daddy said it was too much to shear them, and I could show them when I could shear them myself. And when I was old enough to shear them myself, I was smart enough that I didn't want to go down that road. So
But you didn't learn
no, I
because
did not, because truth be told, that's what we raise personally. And my children show market lambs today, and it's a every weekend type of event, so it keeps me very busy.
awesome.
But I was fortunate enough to be involved in 4-H. Really wanted to be at Penn State when I graduated high school, but ended up going south to West Virginia, and was indoctrinated into that program. Really fell in love with the idea of studying the realm of reproduction. My mind, the way it works, is always thinking about that next generation and how do we get that next generation on the ground. Um, so I went from West Virginia, got my bachelor's and then my master's there, and then went to Ohio State, and it was actually up at Worcester for my doctoral degree, and played mainly with dairy cattle reproduction because they are always a problem, and was trying to figure some things out there, and then was hired at Penn State. So I finally did make it to Penn State, and was at Penn State for 2 years, and continued to add to that base before being recruited down to NC State. Since being down here, I learned very quickly that it is hot. Moved to North Carolina in August, and I will never forget my dad saying, "You're one of the smartest people I know, but you're one of the dumbest people for moving to North Carolina in August."
Yeah.
And so, but that really set up my research, trying to understand how these animals survive in this hot, humid environment, and that's what I've been doing for the last 13 or so years, is looking at how we manage our ruminants, again, primarily cattle, but have jumped over to doing a lot more on the sheep side since Andrew Weaver, who's been on your show several times, since he joined the faculty, he's really got us excited about that, and so starting to ask questions in that regard now. So
Well,
Yeah,
that's
and
good.
if you haven't figured out, unless you have ties to Ohio State, West Virginia, or the state of Pennsylvania, you probably don't make it onto the show. So, which is not the case, but it's a super, super cool history of how you got to where you're at. And one of the fun things, I was trying to do a little bit of research beforehand, so when I ask a question, it doesn't sound, completely ridiculous. But you go through the sheep production handbook, and the whole reproduction chapter is written by Keith Inskeep, Dr. Keith Inskeep, who's no longer with us. And I think it's neat to see, a product of that system. We think about West Virginia University. I was not part of the repro group, but there's a long history, whether you know it or not, of very knowledgeable, very well known reproductive physiologists that have been there for their entire or almost their entire career. So people like Keith Inskeep, Bob Daly, and to see someone else kind of carry on that, we'll call it a legacy at this
that's right.
point, even though one of those two members is is still alive. But that's, I think, a cool thing. We talk about places and what they're known for, and I think, again, not coming from that section of that program, but see people out and being very successful doing that stuff. There's so many unanswered questions, which is crazy because we've been breeding sheep for thousands of years and been researching for who knows how long. So we're going to jump into some of the basics and explain to us a little bit when we think about the estrus cycle on the female, what you'd tell us if we were sitting in a classroom at NC State, first day of class in repro phys.
Okay, so one of the biggest things that we have to keep in mind with our small ruminants is they're what we call seasonally polyestrous. And that's a big word, a big couple of words, meaning that they are only going to be receptive to breeding during a short period of time. And that short period of time of the year for us in the Northern Hemisphere is when the day is in the fall, when the daylight's getting shorter. One of the things that really amazes me and adds to some of our confusion, I'll say, is that we have some sheep breeds that are very strict, and meaning they have a very short window of sexual receptivity, like the Suffolk, the blackface sheep. They're very tightly conserved. And then on the other side of the coin, we have breeds that bend the rules a little bit. We'll say they'll start to come into to be receptive a lot earlier in the year, and so they're pushing that August 1st, and you start to see them coming in the heat. Whereas the Suffolks, they need that October 1st to really show that good heat. Katahdins are one that they play that neat little game where they're more receptive earlier or have a much longer breeding season. Dorsets are another breed that we tend to think about that have a longer breeding season compared to others. And so that's the first thing that we have to think about, because that's the biggest difference between some of our other farm species like cattle that will breed all year round. And so we have to figure out what's going on with these ewes. And if we put that buck in there, or that ram in there, in July, what are we expecting? So that's one of the first things we have to keep in mind. The other thing is that they will only show that sexual receptivity during the shortened time period. So we creep into the end of February, early March, when that daylight's getting a little bit longer, and they shut down. And then they go into this period which we refer to as anestrus, or no receptivity during our long days. And that's something that every flock seems to differ on how well they'll respond and regulate that. And again, there's breed differences as well. And this is some of the stuff that, as you mentioned, Dr. Inskeep looked at for years of trying to figure out what is regulating that. And we do know it goes back to the brain and is related to melatonin. We take melatonin when we travel to block some of those jet lag effects. Well, that same drug in sheep is what's regulating that estrus cycle, or that period of receptivity. So that's one of the first things that we need to keep in mind. And then the other thing that we need to keep in mind with sheep especially is that they only have a 16-day cycle, meaning that every 16 days, if they don't become pregnant, they'll show that receptivity. Now, this differs from a lot of other species like the goat that has a 21-day cycle. And so if we're thinking about when we're putting those rams in, or if we're using things to help us know which females have been bred, like a marking harness, how quickly we have to change those crayons in order to make sure that we see if they're being remarked. So those are some of the first things that we need to keep in mind. The other thing is they, during that 16-day cycle, they're only going to be sexually receptive for about 24 to 36 hours. So it's a very short period of time in which that ram has the opportunity to breed that female.
And that would be considered our standing heat.
Correct. Yep. That's when they're standing to be bred.
I feel like there's a we have a lot of advantages in the sheep industry when it comes to reproduction, the ability to twin, the ability to that short gestation interval. So we can get multiple lambs out in a, or multiple lambings out in an increased amount of time. So as opposed to an annual cycle of, cattle are going to give you one calf every 12 months, hopefully, if they're being managed correctly. Sheep, we can produce twins. If we're accelerated, we can get 3 lambings in 2 years. Well, we might get 6 lambs in 2 years. But one of the disadvantages is I can go out and look at a group of cows, and if I'm avidly paying attention, I notice which ones are in heat, which allows for some reproductive technologies to be implemented far easier than what we have in the sheep side of things. The other aspect, we think of like the actual physical differences. Transcervical artificial insemination, not really an option. Do you mind telling us a little bit why that is and kind of the structure internally that we don't see?
Sure thing. So, the reproductive tract among all ruminants is very similar. In cattle, as Cam mentioned, we are able to artificially inseminate cattle. One, due to their size, we're able to use our arm and actually palpate the reproductive tract. And then the second component is the cervix. Now, the cervix is an organ that is in between the outside of the world and where those lambs are going to grow in the uterus during gestation. So in the cow, there's an interlocking structure we've referred to as annular rings, and they lock together like if you put your hands together and your fingers connecting. In cattle and goats, there's generally 3 or 4 connecting that outside vagina to the uterine inside of the uterus. In sheep, if we look at the reproductive tract of sheep, there's anywhere from 9 to 12 of those rings that interconnect. And so we don't, it's much more difficult to pass an inseminating rod through that cervix because there's so many rings, and the physical size of that we're not able to manipulate the cervix in order to aid us in bumping that rod through the cervix. Again, when we're artificially inseminating, our target is to put the semen in the uterine body, because we're using a much smaller dose, smaller concentration of sperm cells, much smaller volume than what that buck would be delivering when he naturally inseminates that female. So that physical barrier is necessary to help create a unique environment where those lambs are going to grow through that 5 months gestation. But it also is one of those hindrances that that really prevents us from advancing that technology in that method. We do have other opportunities that we see. There are folks that are doing artificial insemination in their flock, and those that are doing it have to use what we refer to as laparoscopic AI, or a laparoscopic artificial insemination. And so basically we're peering into the body cavity with a scope in order to visualize the uterus, and then we're physically injecting the semen into the uterus with a syringe. And that seems to work for some folks. Timing, again, is the biggest challenge that we have. And when I mean timing, I mean when that ewe is actually going to ovulate. In order to create lambs, we want to time it perfectly so that we have the egg or the oocyte there and we want to deliver the semen or the sperm cells at that same time. Not all the ewes read the textbook and follow the right set of rules. And so we'll see differences in the timing of ovulation, even though we use other technologies like synchronization that we can chat about another time in order to help group them up. The ram, on the other hand, he's going to breed that ewe as many times as she'll let him in that 24 to 36 hour window. And when he's depositing his ejaculate, there's going to be anywhere from 9 to 12 billion sperm cells. When we do artificial insemination, we reduce that number down to 20 to 40 million. So we're really disadvantaged by trying to use this technology for several different ways. One is the anatomy of the ewe, the other is the sperm concentration, and unlike the cattle industry, we don't have we have breeding soundness exams, but we don't have the same rigor yet on the male side with our rams that we do in the bull side. So on the bull side, we have our criteria for what it takes to freeze sperm cells in order to have that success later on. We're still at that learning phase for the sheep and goats. We have some companies out there that are really advancing our knowledge. We have some universities that are advancing our knowledge, but we're not quite there yet. We don't have the same type of certificate of semen analysis like we do on the bull side. So the quality of our frozen or fresh sperm cells that we're using may be a little questionable as well.
Yeah, it's interesting to kind of see those differences across species. I know one thing that was brought to my attention when I was with Penn State, and Dr. Tara Felix was doing a project with some beef on dairy, looking at calves, taking beef bulls, putting them on dairy cows, and then how those calves perform in the feedlot. So her goal was not to look at the reproductive side of things, but one of the aspects of the project that came up was volume of semen produced from beef bulls to our dairy bulls, meaning like beef bulls are producing fewer straws of semen than our average dairy bulls. There's probably some factors going into that, if those beef bulls are actually going back out to the ranch and breeding naturally. Maybe they're not at that stud for as long as what those dairy bulls that live there 12 months out of the year. But what you were just talking about, the concentration of sperm that's provided naturally versus what's provided artificially by us when we do that artificial insemination, and then the need for research. It's just going to take time and freezing more samples, because I'm sure there are rams out there, whether it's in the club lamb side of things or if someone's doing it on the commercial side, that thaw better and perform at a higher level when in that uterine body, when in that uterine horn to fertilize that egg, than what some other rams do. And so how do you, and this is an out there question, how do you start to evaluate the difference in that sperm cell, in that semen concentrate after it's thawed? Like, you put it on a slide and just watch?
Yeah,
That's fascinating.
So that's the best way. And that's pretty much what we're doing right now, is that we'll go ahead and if we're using this technology of artificial insemination, we'll go ahead and inseminate that ewe. And then before we're done with the process, usually we have a technician go over to a scope, put a droplet of that frozen straw on a slide to check what is the motility. That's one of our quickest and easiest ways that we can assess the sample. And we can do it as simple as high, medium, and low. Some folks will say, all right, they'll ask themselves mentally, is 100% of the cells moving? And then just do yes and no's. Yes or no? No, not 100. 100% is not modal. And so then they jump down, is 50%? Yes. And so we narrow it down that way to get an estimation. And, it's one of those things, if we don't record it, we can't analyze it. And so we're at that point where we're really gathering that information now as more and more people are taking the risk to do artificial insemination. I do want to step back and say, this is one of the things that has me very excited, because small ruminants are still the reproductive enigma. They don't follow the rules. And it really has me excited about, we think we got everything going in the right direction, and then we do our preg check and we have a train wreck when it comes to adding these reproductive technologies into our flock. And so we're still at that collection phase as more and more folks are experimenting with it. We as long as we can get that data collected, we'll have a better idea. In addition to the motility side, some folks are going a step further, and they'll actually take that droplet that they're looking at. They'll actually kill the sperm cells because we need to kill them in order to visualize them, and they'll look for morphology differences. So the sperm cells should have a very characteristic morphology, which is a round or oval head and then a relatively straight tail. And so we'll look at for different differences in those sperm cells. Some of the common challenges or morphological differences that we'll see that will hinder fertility would be an abnormal head or an overly large or small head. Those are going to change how that cell is able to swim. We see some with multiple tails or broken tails. And if we do that morphological assessment, that gives us, again, another idea of where these animals are. So let me give you some real world examples. So if we have a very young ram, we'll see usually motility will be okay in a young ram, but we'll see a lot of morphological abnormalities. As that ram continues to mature, we see the number or the percentage of abnormal sperm cells decrease. And so as we're developing these rams in our systems, if we do that semen collection and analysis early on, we just like in the bulls, we'll see more abnormal sperm cells, and then as that ram gets older and gets better, we'll see more and more normal cells. Morphology is linked to motility, and so abnormal sperm cells do not have good motility, and so we'll see those criteria move as that ram matures. And so sometimes we'll need, if we got a young ram that we're testing, sometimes we'll need a couple tests in order to confirm that he is a potential satisfactory breeder.
So if we
Go
do
ahead.
some vocabulary real quick.
Yep.
So defining morphology and defining motility, just in
Okay.
case and the audience isn't familiar with those aren't terms that we use. You might use them every day. Most of us, unless we have a negative BSE, hopefully we're not talking about it other than, if we're a repro physiologist. So
All right. So motility, there's two ways to define motility. One is just general movement, and that's a broad term for motility. And then we actually add a little more description to it, and we call it forward progressive motility. And so forward progressive motility is ideally what we want, because that indicates that the sperm cells are swimming in a straight line. General motility counts those sperm cells that are going to swim in a straight line, but it's also going to count those sperm cells that are just spinning in circles. That's motility as well. Those guys that are just spinning in circles, they're not going to be able to transverse that female tract and create a pregnancy. So ideally, we want forward progressive motility. And then when we talk about morphology, we can equate morphology to like phenotype. And so what does the cell look like, physically look like? And again, when we talk about morphology, it should have an oval to roundish head, and then a straightened tail, and that'll allow it to have the proper forward progressive motility. If it has two tails, this is one of the most common abnormalities we see. If it has two tails, that doesn't mean it goes any faster. They just actually spin in circles a lot quicker. So they are going to be modal, but they're not going to go in a straight line. So there are some guidelines out there for rams, and we use very broad terms on the cattle side, and those broad terms are potential satisfactory breeder or potential unsatisfactory breeder. So very, very broad terms that we use on the cattle side. And in the small ruminant side, again, we're still in this data collection side, but we label them as either excellent, satisfactory, or questionable based off of that semen analysis. And so when we're looking at motility and morphology, for an excellent animal, we're going to have greater than 50% motility and greater than 90% normal morphology. A satisfactory ram is going to be one that's going to have greater than 30% motility and greater than 70% morphology, so normal looking cells. And that's actually the same criteria we use for bulls, that 30 and 70. Questionable then is under 30% motile and under 70% normal morphology. Now, if we have a ram that's questionable, we can retest him, and he has the potential then to pass on that next test, especially if he's a young ram. So one of the things that we know is that from start to finish, it takes that ram about 48 days to make a sperm cell. And so if we're going to test, say we test him today and he's a questionable breeder, we can come back in 30 days, test him again, and that'll give us an idea of whether he's going to breed ewes or not, and whether his semen will pass that evaluation. Again, it takes 48 days to build those sperm cells. So what happened 48 days ago? It was hot, it was dry. That environmental impact could decrease his sperm quality or his ability to produce sperm cells. And so then we advanced 30 days and the weather got better. And so also the daylight got shorter. Rams follow pretty much the same daylight patterns as ewes. They're not quite as restricted as the ewes are with sexual receptivity, but we do see that suppression in our summer months during those long days in rams as well as we do in ewes. So all this comes into that factors.
Yeah, and we have some heat playing into those summer months as well. And I think that's always been kind of the challenging thing when we look at, maybe we want to breed in September to get some February lambs. We know those ewes are going to be cycling. Those days are getting shorter. And but the ram was, if we had him out grazing, sun beating down on him, I mean, hot, humid North Carolina in July, there's a chance he may not be fertile. But it is interesting on the like seasonality aspect of this. Will rams go completely infertile in the spring if there's a breed that follows a seasonality pattern like we talked about earlier, or is it just a reduced concentration of sperm, or maybe some of those motility morphology differences that time of year aren't firing on all cylinders? Do you mind like diving a little bit deeper into that, because that's very interesting?
So this is one of those neat avenues, and there's not a lot of data out there, but we do know. So it's very hard to shut off the male system. I'm going to start by saying that. And so we do see a reduced number of sperm cells being produced in the summer months, but because that male is producing billions of sperm on a daily basis, it's like 1,000 sperm cells per heartbeat is the turnover and production. So a lot of sperm cells being produced. It's really hard to shut that off. You know, on the male side, they focus on quantity with those billion cells. On the ewe side, she's focused on one or two very high quality oocytes. So it's much easier to turn off those one or two than it is to shut off that machine or that factory of the testis. So we do see a reduction in the number of sperm cells being produced. We also see a reduction in that ram's libido in the summer months because of the daylight, because in our area and the heat. And so those factors also play into it. Because his libido is reduced, he's not willing to breed. We don't have that turnover of sperm cells in the male tract. And so if we would attempt to breed those males in the summer, there's going to be some stagnant cells, let's put it that way, until he's able to get cleaned out and have a fresh batch released.
Oh, you muted yourself, Cam.
Yep. The libido aspect of all this is, I think, really interesting. And I know if you run multiple rams in a group or around breeding season, there are some differences. There's a ram we've got out in the field right now with all the other rams, and he would rather sit there and pace the fence. There's a field in between ewe lambs and the ram pen, but he will pace the fence, and especially morning, evening when it's cooler, middle of the day, he'll go find, some trees. But that's all he wants to do is go out and breed. And there's other rams that are out there that they acknowledge it, but they're more worried about going and eating grass and lounging. Yeah, how does that libido factor into, I guess, breedability? So
Yep.
how many ewes can that ram cover? Is that a significant driver in just reproductive efficiency on the male side? And is there a way we can select for that other than sitting there with binoculars looking at rams on the fence?
So libido is probably the hardest thing for us to assess in that breeding soundness exam, because we don't know what his willingness is going to be until we put him with a group of ewes. We ideally say a mature ram will cover 25 to 30 ewes in a breeding season, and we can use those numbers. Now, if they're synchronized, and they're all going to come in within a very tight window, we need to reduce that down, because a good ram will try to kill himself breeding those ewes. The other thing is, I actually saw on social media a question that came up about multiple ram systems. So if you have 100 ewes and you need multiple rams in there to cover that number of ewes in a given period of time, how many do you use? One of the things that I've seen and feel very strongly about is, if you need 3 rams to breed the number of ewes you have, get a 4th one in there, because what tends to happen is 2 rams will sit there and fight each other with these ewes coming in heat, and that other sneaky sucker is going to go around and try to breed everything else. And we see that in our progeny, if you do progeny testing, or sire testing. And so if you have 4 rams in there, that likelihood of 1 ram breeding everybody or trying to breed everybody isn't occurring. We do know that the strength of the libido of that ram will dictate how well those ewes come into estrus. And so if we have a ram with a very strong libido and is producing a lot of pheromones, we have something called the buck effect in the ewes. And so the buck effect is, if we can keep the rams away from those females for about a 60-day period, and when I say away, no sight, no sound, no smell of that ram, and then we reintroduce that ram, just his presence and his smell will entice those ewes to come into estrus a lot quicker, or be sexually receptive quicker. And it's usually about a 7 to 10-day period in which they'll respond and come into heat. So those rams with the higher libido tend to have that more muskier smell, and they will induce those females to respond a lot quicker. But unfortunately, where we're at with libido is that simple watching, putting them in and assessing, what does that ram do when we put him in? Does he go to the feed bunk, or does he automatically start pestering those ewes, chasing them around, regardless if they're in heat or not? What is he doing when we add him into that group? So,
Yeah, I'm not saying there's any type of like research basis or any fact to this, but I do know this ram, he's a yearling. We used his sire last year, and that sheep could have, when I would get in the pen and we put that sheep into the pen with those ewes, I mean, could have just would have jumped any gate that you would have had in between him and ewes that were coming into heat. So it's kind of interesting to see, is there a genetic effect to, like, impact of libido from sire to son? Do we know enough about it to even make a claim about it, or say that, hey, there's a possible area of research around this? I don't know how you'd measure it, and I don't know if it's even worth it, but
so there is some speculation that there is a genetic component to it, but we don't have that collected yet. I will say that. And then this is one of those, we need grad students to go out there and just visually watch what's going on and spend hours doing it. Although we're getting more precision ag out there, and so we can use cameras to record it and then have to watch the recordings.
AI, artificial intelligence
That's
Yep.
right.
for libido.
That's right.
Awesome.
But
No,
it is that time of year. A lot of people got their rams in with their ewes right now in order to catch the advantage of those January, February lambs. And for those out there that are breeding their flock right now, I wish you all the best as we wrap up this section.
yep. Well, we're coming up on our time here. It's been very, very interesting. I've got a ton of questions, so we're probably going to have to do another episode for sure. Because
Might be two, Tom.
maybe
Might take more
three.
than one.
There might
Yeah.
be three more. I don't know. There's quite a bit. So we thank you for listening to another episode of the Grazing Sheep Podcast. There's a YouTube channel. There's a Facebook page. If you got some questions, comments, you can reach out to me at bigtomperkins@gmail.com. So I'm excited to see what else we get into in these next podcasts. Like I said, I got a ton of questions. So we'll talk to you guys later then.
Very good. Thank you.
All right.
Sounds good. Thank you,
Yeah.
Dr. Poole.
Yes, thank you. And from NC State.
That's
Bye.
right. Go
Yep.
Wolfpack.
Go Wolfpack. All righty. Talk to you later.
Have a good one.
Bye.